I think the major difficulty with prostate cancer is distinguishing those cancers that are more aggressive or may become more aggressive, and therefore may spread to other organs or may be resistant to treatment. So that the prevalence of prostate cancer is very high amongst men in this country and throughout the world. But many of those cancers will remain relatively benign and won't actually do any harm to the patient. The really key problem that we're trying to solve is to distinguish those cancers that are relatively benign from those that will become more aggressive. That's the difficult problem. One of the central aims of our project is to distinguish those men with prostate cancer that require that severe treatment, but also those men that actually don't require that treatment, so we can spare potentially thousands of men unnecessary treatment and the associated side effects.
In breast cancer, there's 4 or 5 really well-defined subtypes, and they have different treatments. They have drugs that work in one subtype and not the other, and also different prognosis. So people working in the breast cancer field have got a much better idea of how to treat these patients. And actually, the outcomes have been massively improved with breast cancer over the last 10 to 20 years because of this. In prostate cancer, we don't have this at all. So even though we know there is a wide range of different outcomes, we don't have the subtypes or an understanding of these subtypes to determine the best treatments for patients. So my ideal would be that someone comes with a potential diagnosis of prostate cancer, they do a test, it then determines the subtype of disease that patient has, and then they have targeted treatments for that particular cancer type, and their chances of survival is much improved.
We will extract the DNA from cancer cells, and we'll analyse the DNA to find all the mutations in these cells. This generates an enormous amount of data, and there's actually too much data for us to analyse by hand, just using kind of human ingenuity. So we have to use special techniques that can work with really large amounts of data and find patterns in that data. And so we typically use methods that are inspired by human intelligence, but actually put into the computer. So we use methods like artificial neural networks, which are where you use the computer in a way that it's kind of modelled on the way that the human brain works in terms of neurons, but actually is carried out much faster and can deal with really large amounts of data.